Linear differential equation.
All right, people. Today's lesson we'll be looking at differential equation, and we'll be looking at simply the introduction of what a linear differential equation. That is how you can identify a differential equation as what as linear. That is basically what we'll be looking at today, and it will take about only 5 minutes so that we'll be done with it and move to the next lesson. All right, so now, generally, if you see an equation in this form, it is what a linear differential equation where you have a of x, e of n, x y exponent n, e of n minus 1, so there is a reduction, y exponent n minus 1, so there is that correlation till we get what? A naught y giving us the function f of x. And we say that the functions a n of x, that's the a n of x, are all functions of x and they are not equal to 0. And those two should have a constant coefficient. So the constant coefficient is more or less like what? The an. So now we can get maybe 2 of x. You get it? So 2 of x, it has a constant of 2. But it is a function of what? Of x. Alright. So now what happens is that before you can really identify any differential equation you are given to be linear, there are 3 conditions that is really expected. And I just want us to quickly go through the conditions. So now, the conditions of linearity. The conditions of linearity of a differential equation. Alright. So now, with the first one, no product of dependent variable. The differential equation shouldn't have a product of the dependent variable. Shouldn't have a product of the dependent variable and its derivative. And its derivative in the differential equation. Now, the first thing I have to take note is that with the conditions for linearity, there shouldn't be any product of the dependent variable and its derivative in the differential equation. For instance, if I have a differential equation of dy over dx plus y is equal to 0, can we say this differential equation is linear? Can we say this differential equation is linear? Yes. It is what? Linear. Why? Because there is no product of the dependent variable with its what? Its derivative. So it is what? It's linear. Now in other case, let's write y of dy all over dx plus y is equal to 0. Now here, what is the dependent variable here? When you consider this equation, what is the dependent variable here? It is y. Y is the dependent variable because it's the denominator, the derivative. But you can see that the dependent variable x multiplying the derivative of what? It's multiplying its derivative of what? In the differential equation. So an equation like this, it is what? Non-linear. An equation like this is what? It's non-linear. So anytime you see a differential equation, where you see the dependent variable multiplying its derivative in the differential equation, then that differential equation is not linear, a linear differential equation. All right. Now the second condition is that the dependent variable in the differential equation and its derivatives must all be of the first degree. So now, this is the second thing. The dependent variable and its derivatives must all be of the first degree. The dependent variable and its derivatives must all be of what? Of the first degree. So if they are all of the first degree, then there is no what? There is no problem. So for instance, this example here, the dependent variable, and its derivative, they are all of what? Of the same what? First degree. They are all of the same what? First degree. So you can have also an example like the square u over what? The t square plus what? Plus y plus 2t squared is equal to what? 4. So when we have this equation here, for instance, what happens is that there is an independent variable here which is t, and there is a dependent variable here which is y. But this dependent variable here which is y has a degree of 1, and this also over here has a degree of what? Of 1. So its derivative and itself, they are all having a degree of what? Of 1. So it makes it what? A linear what? Equation. It makes it what? A linear equation. Alright. So now let's look at the third point. Let's look at the third point, which is the last condition for what? Linearity. And with the last condition, we say that the dependent variable, we say that the dependent variable should not be in the form of logarithm. The dependent variable should not be in the form of logarithm, 2 exponential, and 3 trigonometric functions. So if the last condition for linearity is that the dependent variable should not be in the form of logarithm, should not be in the form of any exponential functions or trigonometric functions. So let's look at some differential equation like this. Let's say the square y on the x squared, let's say plus y cos omega t is equal to, let's say, 2. If you have a question of this nature, or let me write as cos y of what? Omega t. You realize that the dependent variable is now having something to do, or it's now in the form of what? A cos function, which is a trigonometric function. So it makes the whole of what? This equation what? Non-linear. The dependent variable should have nothing to do with the form of logarithms, exponentials, and trigonometric what? Functions. And if all these conditions are perfect, then you can actually tell that a differential equation is very linear. Alright? So thank you for joining this class, and let's move on to the other concept.